Hey everyone, Mr. Voikin here, and we're going to take a look at the third breadboarding circuit, and that is adding in a variable resistor. A variable resistor is exactly what the name implies. It is a resistor that can vary. So far we've looked at fixed resistors, which have a manufactured fixed value, and we select the resistor value that is going to work best in our circuit. So right now you can see I've got a breadboard set up, connected to a 9-volt battery, and I've connected all the ground rails and V plus rails. This one needs to be changed to a red color to have proper color coordination. Why won't you change? There we go. Red. Okay, and now according to the diagram, we basically have this all set up down here, which is my ground rail, and I've got the V plus put in, and it's going to be going all the way to there, and I've also got my ground connected to the breadboard, but you can see we still have to go through that switch, that latching switch, and through the protection diode. So we did this in the last circuit, so I'll do it quickly by bringing the switch over and popping that in and taking a diode and rotating that and bringing that down to ground. So that essentially completes that portion of the circuit. Now we need to add in our potentiometer or variable resistor. So here is the potentiometer right here, and you can see that it's set to a default of 250,000 ohms or kilo ohms, pardon me, and our drawing is asking for a 200K. So I'll just quickly change that. And on the diagram right here, we've got leg number 1, leg number 2, and it says terminal 2, but that's leg number 3 according to these numbers on the schematic symbol in our schematic drawing. So on the schematic symbol, we have leg 1, 2, and 3. 2 is in the middle, 1 is on the left, and 3 would be on the right. So we can see right here in the drawing that leg 1 is actually not connected to anything, but what is connected, the middle leg, leg 2, is connected down to the ground rail. So I'm going to slide this right down here, pop it in like that, and we'll grab a black wire because we're going to the ground rail with the middle leg like so. And what is leg 3 connected to? Well, if I follow the schematic diagram, I can see it's connected to the negative side of an LED that is red. So I'll grab that LED, put it right there. Here is the cathode, the negative side. So we're going to run a jumper from here to there, and we'll change that to yellow. Looks good. Now I'm essentially on my circuit done to that point, and I only have one more component to put in. That is a 270 ohm resistor. That's done with my calculations again, setting up for 30 milliamps of current, but as we have seen in past videos, Tinkercad only likes 20 milliamps of current going through there. So with a voltage supply of 9 volts, we're going to want to put this at a 330 ohm resistor. So if I'm breadboarding it, 270 should be fine, but we are going to take this and essentially put it like so across there, and we need to now change that to 330 ohms. And I need to, again, take another jumper wire over to my resistor. And because we're going to take the resistor up to the positive rail, we'll change that to a red wire so we have proper color coding. Make that last jumper, and that's it. The circuit should work right now. So that is done. Oops. There we go. We need the highlighter. That's better. All right, so every line and every component is highlighted, so that means the circuit that we've built should be identical to the circuit that is in the schematic drawing. So let's test it out. We'll start the simulation, turn on the power, and you can actually see the LED did turn on a little bit. So very, very dim. And now as I turn it to the right, it should start to get brighter. There it is. Now it doesn't happen until almost the very end. That's because down here there's just way too much resistance and it's not allowing much current at all to flow through. So if I stop the simulation and change this value of this, say down to like a 10K, that should give us more of the potentiometer to play around with to allow for more dimming of that LED. So let's try it, run the simulation, and it's bright, 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 and you can see, yeah, we're able to get much more, and then it starts to dim, sort of. A little bit better, and you could play around with those values and see how it works. And you can do the same thing with the real circuit when we're breadboarding it in class. Okay, so that is our circuit right there. However, you might be asking yourself, why do we put in a fixed resistor of 330 ohms if I've got this other resistor in there? So it should work without this resistor, and let's just check that out. So if I pull that resistor out, and I'll just pop a little jumper wire in right there that's going to take it up to ground, and I start the simulation, and yeah, there you go, it seems to be working, right? So why did I put that fixed resistor in there? Well, down at when I take this dial all the way to this end, because it's a 10K potentiometer, that means it's at its maximum resistance value of 10K. And now when I go all the way to the other side, it's actually going to hit 0 ohms of resistance, which we know if we have 0 ohms of resistance and 9 volt supply, we're going to kill that LED. And as I swing this down, boom, it should blow up. There you go. So let's put it into the safe zone, stop the simulation, remove that ridiculous jumper wire, and put that safety resistor back in there, start the simulation. Oh yeah.